Yes, good evening, friends. Welcome to the session once again. I hope you all are doing good. Today, we will be discussing the part 3 of geography, environmental section of geography. Okay, we have already completed two parts, that is part 1 and part 2. Today, we will be discussing the part 3. As we wait for some more learners to join in, before going into the session, let me just give you some news or information from the Unacademy platform. You see here, from Unacademy platform, we have this introductory offer for the person who are going to appear for this UPSC CSE 2023. The last date was till 12th of January, but because of popular demand, it has been extended up to 19th of January. Now the point is, the actual price of this 18-month combo course is 78,999. With 10% discount, you will get around 79,998. But one interesting feature is, with the use of this educator code, you will further get a discount. So in total, you are getting a discount of around 15% with the use of this educator code. So you can use my educator code, that is SUNEP10. Okay. So the 18 months combo, which was 78,999, now you are getting by 63,898. Clear? And it is valid up to 19th of January. It is not the only thing. You are also getting additional benefit of books. You will get access to 20 GS book, which is specially curated and designed aligning to the recent trend in the UPSC. Along with this, you will be able to get a chance to attend this test series. If you haven't subscribed till now, what you are waiting for? Such an amazing offer, you kindly subscribe to it. Unacademy platform always comes up with various programs, various courses, various programs. Now, one of the example is last year, there was a program by the name of Last Mile program. Now, the success rate of this particular Last Mile program is, in the recently announced UPSC result, from all Indian rank 1 to 20, 7 learners were there from this particular program. From all Indian rank 21 to 100, 20 learners were there. All Indian rank 101 to 761, around 143 learners were there from this particular Last Mile program. So if you want your name to be there in this list of successful individual like this, you kindly subscribe to the programs and the courses which get launched in the Unacademy platform. Depending on the Unacademy platform launches certain programs depending on the relevance, that is depending on the upcoming exams, so on and so forth. So you kindly subscribe to this. Okay, your prelims exam is there, 2022 prelims exam in the month of June. You don't have much time now. Taking this into consideration, from Unacademy platform, we have this comprehensive batch course on GS. It is starting on 19th of January. So you kindly subscribe to this if you are preparing for 2022 as well as 2023. You have this, for 2022, you have this Mission 2022, Lakshya 2022. For 23, you have this Mission 2023, Expedition 2023, Lakshya 2023. Clear? Every Sunday at 11 a.m. in Unacademy platform, we have this UPSC CSE Compact. Therefore, I strongly suggest you kindly attend to this Compact. You lose nothing, you only benefit. There are only certain things in life where you lose nothing and get, and this is one of those. So this upcoming Sunday, that is day after tomorrow, 16 January, you have this Unacademy Compact. You kindly attend. you will get a scholarship from a pool of around 4 crores of rupees, and also at the same time you will get a chance to self-assess yourself, okay, which is very, very important. You can use my educator code to enroll in this particular test. That is, you can use my educator code, that is SUNEP10. Clear? With that basic introduction, let us continue with our discussion today. In the last class, we have seen the photosynthesis efficiency, or we have seen in the last class, we have seen this photosynthetic efficiency, okay, during our discussion of energy flow in the ecosystem in the last session. This energy flow comes from where? Okay, we are discussing ecosystem. Under this ecosystem, we have structure of the ecosystem, that is abiotic and biotic component, and also under ecosystem we have function of the ecosystem. Material or the nutrient flow in the ecosystem is one function. Other function is the energy flow in the ecosystem. Right now we are studying this energy flow. So in this energy flow in the ecosystem, we know the plants are the only organisms or only species which can capture the sun insolation in order to construct their own or manufacture their own food. And after this, it is consumed by others, and that is how the energy flows in the ecosystem. We have already seen this yesterday. Photosynthetic efficiency is the amount of solar insolation which is falling on the plant. Only around 0.2% is able to be captured by the plant in order to manufacture their own food. Okay, now productivity of an ecosystem is the amount of organic matter accumulated at any unit time. That is known as the productivity of an ecosystem. It involves the study of energy flow through the ecosystem. Now, depending on this, we have different types of productivity, that is primary productivity. What is the meaning of this? Rate at which energy is stored by the producer, that is the green plant, in the form of organic matter, that is known as primary productivity. Gross primary productivity depends on the chlorophyll content of the solar insolation. We all know that the gross primary productivity is 0.2%. See, the general term is primary productivity. What is this primary productivity? It is the rate at which energy is stored by the producer to form the organic matter. Like the green plant observes the sun insolation, manufacture their own food and store here in the form of organic matter. That is primary productivity. But in this primary productivity, the first subcategory is a cross primary productivity, which is nothing but the photosynthetic efficiency that we have seen just now. That is 0.2%, which is the sun insolation which is coming. Only 0.2% of this sun insolation is able to be captured by this green plant. Others, remaining energy, 99.8%, it just dissipates. The green plant is not able to capture that amount. Okay, now, and this cross primary productivity, which is 0.2%, depends on the chlorophyll content which is responsible for the manufacturing of the food with the help of this insolation from the sun. What is this net primary productivity? Okay, net primary productivity is, you see here, we all know that yesterday also we have seen the green plant which manufacture their own food under the influence of sun insolation, okay, captures only 0.2% of the sun insolation. That's why we call it as a cross primary productivity. Out of this, okay, out of this energy, you can say, out of this, the plant also requires certain amount of energy in order to maintain their own system, that is metabolism, whatever it is. Therefore, the net primary productivity is the amount of energy that is available for the next stage. Some organism will consume this, no? So the energy available for giving out to the organism that feeds on the plant is known as net primary productivity, you can say, after subtracting the energy that is required by this organism itself. That is, the energy required by the plant itself in order to maintain their own system. Now, distribution of primary production, agricultural system is not as productive as many of the natural ecosystem. Let us see the net primary productivity, okay, or the productivity of the ecosystem itself. Kindly look at the diagram in front of you. The figure which is written at the top, that is, if I go from left to right, it is less than 2.1, this one. Now you focus here in this section. This is the productivity of ecosystem. What ecosystem? The ecosystem is represented by the bottom line, this one, which means you see here, this particular ecosystem is nothing but the estuaries, the coral reef, the spring, okay, all of this, alluvial plain, all of this is nothing but the ecosystem of this, coral reef ecosystem, estuaries. Now you see here, it is having the maximum productivity. And if you watch it very, very closely or keenly, you will find it is a transitional area. A transitional area between terrestrial ecosystem and marine ecosystem. You see here, this is a water body, this is ocean, this is land. It is a transitional zone between marine ecosystem and terrestrial ecosystem. Clear? It has got the maximum productivity. Clear? So, such kind of a transition region between terrestrial and oceanic region has the maximum productivity, followed by moist forest, okay, shallow lake, moist grassland and moist agriculture represented by this particular region. Okay, see, in your exam, especially in your prelims, there may be a question like they will give you different ecosystem and will ask you to arrange them in ascending or descending order regarding the highest productivity to the lowest productivity. It can be a match the following also. Clear? Now, this is followed by this section in the terrestrial area and in the marine area by this. That is grassland, deep lake, mountain forest, continental shelf water. So this is the highest productive region, followed by this, followed by these sections in the land and in the water by this. Now, you go, the fourth one is this one, less than 4.2 or 4 to 2, that is the deep ocean. Then comes the less than 2, that is the desert, okay, that is 5. So broadly, the productivity of the ecosystem arranged in this manner. Further, same thing but mentioned here by the name. See, this is type of ecosystem that is in this particular section, and this is the average net primary productivity. Okay, now you see here, estuary having the highest productivity, followed by swamp and marshes, almost the same. Then the tropical rainforest, almost the same. Then comes the temperate forest, which is less than these three. Then it is followed by northern coniferous forest, that is the daika. Then followed by the savanna, that is the grassland. Then followed by agricultural land. That's why we say agriculture is not that much productive in nature. Okay? Woodland and shrubland is followed. Then comes the temperate grassland and lake and stream here. Remember, savanna is also a type of a grassland, you can say. Tropical grassland, you can say. Now you compare this with a temperate grassland. Both are grassland, but the productivity is different in different latitude. One in temperate latitude, one in tropical latitude. Then comes this continental shelf, open ocean, tundra region, that is Arctic and Alpine. Then comes the desert. Okay, desert scrub and the proper desert, that is the extreme desert. So across the world, if you go from one place to the other, this is how the productivity of the ecosystem varies. At least some question is assured in the exam from this section. Okay. Now, till now, what we have discussed is regarding the primary productivity. Okay, primary productivity. Now, let us come to the second, that is secondary productivity. Now you see here, the rate of production of animal tissue by the consumer after consuming the producer. Here in this case, the producer will be the green plant. So, organism or the animal after feeding the green plant, okay, which is the producer, the animal organism which feeds on the green plant or the producer is an animal, which means they are going to make up their own animal tissue. It can be human being also. Okay, by the consumer is known as net productivity, that is net primary productivity minus the consumption by the consumer itself, that is known as net productivity. That is secondary productivity, which means net primary productivity, as I already told you, the gross primary productivity was the energy which was observed by the green plant. 0.2%. That particular 0.2%, the plant also needs certain energy in order to maintain its own system. Now, the net primary productivity is the amount of energy which is carried forward. That is, a consumer when consumes the producer will get that energy. That is nothing but the net primary productivity here. But the organism that consumes this producer also, similar to the plant, needs certain energy to keep its own system or maintain its own system. Therefore, you subtract this, the remaining energy again for the next higher level is known as net productivity. That is rate of production. Clear? Now, organism occupying the higher trophic level exhibit the following characteristics. Okay, higher trophic level, in a sense, you see green plant, it is consumed by some herbivorous. Herbivorous is consumed by some carnivore. Means if you go in this manner, we call it higher trophic level. Okay, like this. There are fewer carnivore than herbivore and plant, which means you see here, organism occupying the higher trophic level exhibit the following characteristics. There are fewer carnivore than herbivores and plant. Means in a simple food chain, I have these plants consumed by herbivore, on the other hand, herbivore is consumed by carnivore. There are less number of carnivore as compared to plant and herbivore. That is the meaning. There are fewer carnivores than herbivore and plant. Second, carnivore tend to be larger and more generalized in their feeding habit than the herbivore, which means the eating habit of this carnivore is more generalized. Okay, means I can say they can feed on more their feeding is not that much restricted, it is more open. Okay, this carnivore. Now, what is the meaning of this or implication of this? We will see later. Larger habitat requirement and wide geographic distribution, which means for a carnivore needs larger extent of area in order to feed as compared to this herbivore. Okay, which means, see, for carnivore, if I have a land area like this, if here is, say for example, 20 herbivore can be able to live in this efficiently, then in the same area, the carnivore will be less than this 20. Means carnivore require more area, more wide geographical distribution for its survival, or larger habitat is required by the organism when you go higher up the trophic level. Okay, what is the significance of this? We will see. Say for example, let us take the simple example of this simple food chain and food web. Grazing food chain in the land, you see here, plant, squirrel, snake and bird. Now you see here, in this food chain, snake will require, okay, snake is fewer as compared to squirrels, okay, or carnivore tends to be larger, more generalized. Snakes is more generalized in their eating habit as compared to the squirrels, you can say like this, okay. Now plant, fly, spider, shrew, owl, this is one type of food chain. In the water ecosystem, diadem is nothing but the phytoplankton, okay, phytoplankton, this is the plant community in the water. Diadem is able to perform photosynthesis activity under the influence of sun insolation. It is eaten up by mosquitoes, tilapia fish, kingfisher, like this. Okay, so these are simple food chain and food web. Now, important implications of these 3 points which we have just discussed regarding the organism occupying the higher level, you will understand from this Landemann's law. What is this Landemann's law as far as our ecosystem is concerned? It is also known as the law of 10%. You see here, you come to this particular, it is a simple food chain, food web. Primary consumer, primary producer, let us consider this to be the plant. It is consumed by a primary consumer, which is a herbivores. Herbivore is nothing but which feeds on the plant. This primary consumer is consumed by secondary consumer, which is nothing but carnivorous one. Okay, say for example. Now this particular carnivore is also, on the other hand, okay, is eaten by another carnivore like this. Now, important point is you see at this. This is a trophic level, this is a lower trophic level, this is a higher trophic level. Now you see here, the energy which is transferred from one trophic level to the other trophic level, 1000 kilocalorie is here in the plant. Okay, we are taking it as an example. Now, the energy which is fixed in the higher trophic, immediately higher trophic, that is the herbivore, is 100 kilocalories. Now, this is, you divide 1000 calorie by 10, you come to 100 kilocalories. Now, the carnivorous which feeds on this herbivore, again, you divide this by 10, then 10 calories available here. Now, similarly, this carnivore 1, which is being eaten by this carnivorous 2, okay, here you have only 1 kilocalorie divided by 10, which means it is a law of 10%, or Landemann's law, which means, you see, up the trophic level when you go, the energy become dissipated, means less energy is going ahead. Now you see here, the plant which was having 1000 kilocalorie, by the time it reaches the fourth trophic level, that is the fourth trophic level, that is the carnivore 2, the kilocalorie has reduced to 1, which means you see here, this particular organism will require, in order to survive, more area, isn't it? Because this organism is getting less. Therefore, you see here, there are fewer carnivores. First, the number of carnivores should be less. Okay, why? Because less energy is reaching up to the higher trophic. Therefore, compared to the lower trophic organism, the higher tropics, you see here, I have this herbivore getting this 100 kilocalorie, but I have this carnivore getting only 1 kilocalorie. Therefore, this carnivorous population will be less. Okay, why? Because it is getting only a very less amount of kilocalorie, but herbivore will be more as compared to this carnivore. Why? Because more energy is available. Therefore, the number of organism decreases the way the moment I go to the higher tropic region. Therefore, fewer carnivore means less carnivore than herbivores and plants. That is one. Second, carnivores tend to be larger and more generalized in their eating habit, which means since the energy that I am getting is less, if I become a very specialist, okay, if the carnivore becomes very specialist in selecting the eating, then we may die due to starvation. Therefore, they become more generalized. Now, the third important point, larger habitat is required, less energy is reaching. Therefore, they require more area to survive, clear, as compared to the lower tropic level. So, this particular statement about the relationship of organism based on the supply of the energy is this. Okay, I hope that is clear. Things should be very clear. Okay, if you understand the basic fundamentals or the concept, you don't have to remember anything. Okay, the points will just come by itself. Detritus food chain. Let us see. The leaf is eaten by earthworm. Okay, now the earthworm is eaten by the blackbird. The blackbird is eaten by the sparrow. This can be one example of a detritus food chain. Another detritus food chain is dead animal is eaten by maggots. On the other hand, it is eaten by frog, and the frog is eaten by snake. Clear? Now, ecological pyramid. What is this ecological pyramid? Okay, we will go one by one. Please be very attentive. Very, very important concept. Ecological pyramid. Food web. Okay, you see here. Before we go into this, let me tell you. This is food chain. Okay, this is known as a food chain. That is this one. Okay, all of this is food chain. Now, food chain. What is food web? Food web. Food web is nothing but the interconnection of more complicated food chain. Say for example, I can write like this. One particular tropic level 1 results into 2, goes to 3, goes to 4. I can have further connections, like I can have another connections like it is eaten by another 5 or another 3, whatever. It goes here. Again, it is eaten by this. Okay, like this. So more complicated food chain. It is a food web. It is a web. Okay, like this. In the transfer of energy from one level to the other. That is known as food chain and food web. Now, why we need this ecological pyramid in the first place? Before we go and see what is this ecological pyramid, let us see. The food web inability to represent the quantitative relationship between different parts of the biotic component. This food web and food chain that we have discussed just now is not able to provide any kind of quantitative relationship between different parts of the biotic component. Means how much organism, what is the exact number of organism. Okay, in this food chain and food web, in this different tropic level, if I have one organism here or if I have 10 organism here, what should be the number of organism here? It is not mentioned in this food web. The food web is food web or food chain. At best, it is just the indication of relationship among the organism. Feeding habit means one is eaten by the other. On the other hand, that is again eaten by the other, creating different food chain, different tropic level. But regarding how many organisms should be there, okay, the quantitative relationship between the organism is not being able to provide by this food chain and food web. In order to understand or in order to rectify or in order to overcome that difficulty, we introduced the concept of ecological pyramid. So ecological pyramid is, or you can call it as an Eltonian pyramid. It is nothing but the diagrammatical representation of the feeding relationship and energy transfer. How it is done? Number one, we have this pyramid of numbers. Pyramid of numbers represents the number of organisms in each and every tropic level. In order to explain this, let us take the example number A of aquatic ecosystem. In aquatic ecosystem, what taking this aquatic ecosystem, let us try to understand the pyramid of this number. Kindly follow the pointer, important. Okay. You see here, in the aquatic ecosystem, just now I have told you, diadome is a phytoplankton. That is microscopic marine plant organism which is capable of producing their own food with the help of sun insolation. Therefore, in marine ecosystem or aquatic ecosystem, they are known as the producer. Now, this is eaten by primary consumer known as mosquito larva. Now, depending on the size of this diadome are microscopic plant organism in the ocean water. They are very small. Therefore, 700,000 of example, these figures are example figures of diadome. In order to support mosquito of this, 700,000 diadome can support around 4,000 primary consumer, depending on the size. Now, this particular primary consumer, that is the mosquito larva, 4,000 of this mosquito larva as a primary consumer can support 150 number of tilapia fish, that is the secondary consumer. 150 of this tilapia fish is able to support only around 8 kingfisher, which is the tertiary consumer. So, by using this pyramid structure or pyramid of number, I am able to quantify which was the limitation under food web. Food web inability to represent this quantitative relationship, but with the use of this pyramid, I am able to represent the quantitative relationship between different organisms in the ecosystem. The food chain and food web was only regarding the feeding relationship. Clear? Then comes parasitic food chain. Now you remember this. This is, we call it as a pyramid because if it is in the shape of a pyramid like this. Now this is a upright pyramid. Upright pyramid. Now suppose if I invert this, that is, if I invert this, that is like this, then it is known as a inverted pyramid. Clear? Inverted pyramid. Now you come here. Parasitic food chain. This was an aquatic ecosystem. Okay. Now you come here. Parasitic food chain. That is in the land area. In the land area. This was an aquatic ecosystem. We are looking at the pyramid of number. It was in the aquatic ecosystem. Diadome is a microscopic marine plant organism. Now you come to a terrestrial area, terrestrial ecosystem, that is ecosystem of the land. Now, one particular tree that is acting as a producer can host or can give or can feed many fruit-eating birds. Clear? Therefore, one tree can feed 10 birds, fruit-eating birds. At the same time, the secondary consumer which feeds on this fruit-eating bird, 10 fruit-eating bird can support a bird lice of 1,000. Now, the bacteria which feeds on this bird lice, 1,000 bird lice can support, okay, this much. You need 10, 100,000, 10,000 lakh, 10 lakh. 10 lakh of bacteria. Now, you see the shape of this pyramid. This is a inverted pyramid. Therefore, the conclusion is, as far as the pyramid of number is concerned, when I talk about number of pyramid, that is the number of organism that is present in the tropic, in different tropic level. Pyramid of numbers can be either upright in this form or it can be inverted like this, depending on which ecosystem we are considering. In these two examples that we have seen, in the terrestrial ecosystem, it can be inverted type of pyramid of number. In the aquatic ecosystem, it will be a upright pyramid. Clear? Temperate forest shows a mixed shape. Now, so as far as the pyramid of number is concerned, it can be upright, it can be inverted, or it can be a mix. That is, you see here, you come to this particular ecosystem which you will find in the temperate forest. Producer, that is the tree, around 200 can support around 1,50,000 of herbivores. Okay, that is the primary consumer. Now, this particular primary consumer, which is a herbivore, 200 tree can support around 1,50,000 of herbivore, but secondary consumer, mostly it can be carnivore. Okay, mostly carnivore. So 1,50,000 can support only around 600 carnivore. Now the tertiary consumer, again the higher carnivore, can be only one. So in the lower section, it is, or in the lower tropic, it is a inverted pyramid like, but when you go up the tropic level, it becomes the upright. So it is a mixed. Therefore, pyramid of number can be either upright, inverted, or it can be mixed depending on the ecosystem. Clear? This is known as pyramid of number. Any doubt? Now you see here, but there is a basic limitation of this pyramid also. Pyramid of number. It takes no account of size of individual plant or animal. Okay? Under this pyramid of number, one limitation is, yes, under this food web or food chain, the limitation was, it just shows the relationship of different trophic level. Number of organism was not given. So it was addressed by pyramid of number, where the number of organisms in different trophic level is able to be addressed by this pyramid of number. Now, but pyramid of number also has some limitations. What is the limitations? Yes, the number of organism in each and every different trophic level is able to be captured here under pyramid of number. But remember, the size of the organism is not taken care into under this pyramid of number. That is, pyramid of number takes no account of the size of individual plants or animal. Example, shrubs, grass, diadem, tree. One diadem, one tree, they were taken as equal. Okay, size was not taken into consideration. Say for example, I have just mentioned to you, diadem is a microscopic phytoplankton, which means microscopic marine plant organism. So they are very tiny, but the tree, it is a very huge quantity. Now the organic matter, or the organic matter which is present in diadem, in one diadem and one tree, it is a huge difference, but you count as one in pyramid of number. Example, elephant, grasshopper. Under pyramid of number, you count them as one. You bring equivalent. Elephant, grasshopper, you are considering it as in the same parlance or in the same category, but actually they are different. So in order to address this limitation which is there in the pyramid of number, comes the pyramid of biomass. Therefore, in this pyramid of biomass, not only the number, but in this pyramid of biomass, we take into consideration the size of the organism in each and every trophic level. Clear? So we'll end the session here today. From tomorrow we will continue with this pyramid of biomass. Clear? Anyway, thank you so much for your patience and cooperations. We'll end the session here tonight. We will continue tomorrow. Clear? Tomorrow, in essence, we will continue on Monday. Okay, tomorrow is Friday. Tomorrow is Saturday. Sunday we are off. We will continue on Monday. Okay. Bye bye and